Alright, we're going to try one with the calculator now, and I think you're going to really like this, and it's amazing how it does this. So it says on page 477, use a graphing calculator to find the zero, and it says 0, of the function Alright, so in an x cubed we know that we could have 3 solutions, but they're telling us that we only have 1. So here's what we're going to do. The calculator is going to do all the work. So the first thing we'll do is we'll put in y1, the function. And the function is x cubed, x to the third. Don't forget to take your exponent back down so you're not typing it all up there. Then minus x squared and plus 2. Okay, that's the original function. That's f of x. Then we're going to go down and we'll take the derivative of that and put it in there. So we go to math, and number 8 is n derivative x, and here we're going to go to vars over to y vars function, and we're going to hit y1 because it's going to take the derivative of what we just put in. And here we just put x because it's not going to be a derivative that we're evaluating at a point. Okay, and hit enter. So now remember from the formula is x minus f of x over the derivative of x to get your second value. And we need to decide on a seed value, if you will. So I'm going to turn this guy off for just a second because I want to look at this graph and see what you think that we should maybe pick for a seed value. And I'm going to do a zoom standard. Still not showing up. Oh, it's because I turned it off. Okay. So there we go. So the point that we're looking for is this one right here, the 0. Okay, so I don't know. The book says to use -2. We could use -3, whatever we want. So here's the process for doing it. Go to the home screen, and if we want to choose -2, we can. Let's just use -3 to be different. So I'm going to put -3, and I'm going to store that. So I come down here to the store button right here, STO, and I hit that, and I'm going to store it in X. Oops, sorry. X, and get rid of that squared there. Alright. So -3 is going to be stored in X. Hit enter. Now what we're going to tell it to do is we're going to tell it to take X, which is what we just put in there, X minus, remember the function is y1, so we're going to go to vars over to y vars. We're going to hit function y1, and we probably better put that in parentheses, so I'm going to insert a parentheses there, and then divided by the derivative which we stored in y2. So go to vars, y vars, come down to y2, close the parentheses, and now that's going to get stored as our next x. Okay, so store that as x and hit enter. So there's that would be x2. Now watch this. If you hit enter again, there's x3, there's x4, x5, x6, x7, to where it goes to -1. So the answer would be -1. So here we would put x equals -1. That's the 0. All right, so let's try another one. This is on page 478. 93.3. The function is y equals x cubed minus 2x minus 1. So I'm going to go in and clear out my calculator, and we're going to start all over again, but I want to put that function in. So go ahead, you guys, and put the function in. So it's y equals x cubed minus 2x minus 1. So x cubed minus 2x minus 1. And I want to look at the graph of that, because an x cubed could have 3 zeros, and it's really kind of hard to tell right in here without zooming in. And we could zoom in and we'd find out that yes, there are 2 zeros. It does cut there twice. So you know, in the past what we've done is we've used the second calculate and zeros button on the calculator, but it's not nearly as accurate as Newton's method, so we're not going to do that. We're going to use Newton's method. So let's see, how about we put in, let's find this one first. So what if we started with a seed value of 1? Let's start with a seed value of 1 and see what we get. So I've got that in y1. I need to find the derivative. So in y2, I'm going to go math and derivative with respect to x, vars over to y vars, function y1, and just put in x here. Then go to the home screen, so second, quit. And we said we were going to try negative, let's see, for a 0 we could put positive, I don't know, we could put 2. How about let's do 2? So we're going to go 2 stow x, enter. And then we're going to say x minus vars, y vars, y1, divide, oh, I keep forgetting the parentheses, sorry, second insert, parentheses, divided by vars, y2, which is the derivative, close the parentheses, and then store that into x. Alright, so hit enter, and you can't see it. Hit enter again. Again. Okay, so we're going to 1.618. So we're going to call that good. 1.618. So the first 0 is x equals 1.618. Okay, now we'll go back to the calculator. And now, the only thing we need to do is the functions are the same. We just need to have a different seed value. So this time the other two are on the negative side of the x-axis. So we could select something like -1. So I'm just going to put -1 store x, hit enter. Now I have to put it in again, so I have to go x minus parentheses vars, y vars, y1 divided by vars, y vars, down to y2, close the parentheses, store that in x. Now I get -1. Well, what do you know? That's another 0. So I'm going to go back here, say x equals -1. All right, let's go back and look at that graph. Okay, so we've got the one at -1, so it looks like there's one to the right of that. Oh, it graphed the derivative too, sorry. So let's put, how about, I don't know, let's try -0.3. So let's say -0.3 store x. And then, again, I'm going to say x minus parentheses vars y vars 1 divided by vars 2 y2, close the parentheses, store that into x, and hit enter. And hit enter again, because we want to make sure that we're, uh-oh, that's the same one we already had, isn't it? We got -0.618. Maybe not. Let's see. Can't remember. No, this is the negative one. So now we've got the other one is x equals -0.618. Okay, so there's all three zeros, and if you kept hitting enter on the calculator, it would just stay at -0.618, -0.618. It might have a few numbers way over there, but it eventually would come down to -0.618. Now, on some of the problems, it'll ask you, let's see, it'll tell you, like on number 5, it says, use Newton's method to 9 decimal places. So it wants the same 9 numbers after the decimal. Just keep hitting it until you get the same 9 numbers. Number 6 is